So we turn now to sections 3.8 and 3.9, which actually we just have to cover a couple of odds and ends because a lot of this stuff is actually material that we've seen in one form or another. First of all, let's start with section 3.8, which has to do with derivatives of inverse functions, including the inverse of the exponential function. We've already seen when we covered the basic derivative rules that the derivative of the natural log function is 1 over x, so that's not new to you. When we first covered the derivative rules, we had not yet covered the chain rule, but I think you can see that by extension, the derivative of the natural log of some function u is going to be 1 over u then times the derivative of u, because in this case this function u is just the inner function. So we would take the derivative of that function, and sorry, we would just take the 1 over that function and then multiply by its derivative. I'll have an example a little bit later of how that works, but I think that most of you can see just from what you know about the chain rule how that would work. Okay, so let's do one of those now. So let's find the derivative of the natural log of x cubed plus 7x plus sine x. This is basically just a chain rule problem, including with natural log as the outer function, and this is sort of the inner function that I was calling u in the above example, in the above definition. That's the inside function. So just very simply, what we do is we say that this is equal to 1 over x cubed plus 7x plus sine x, and then times the derivative of x cubed plus 7x plus sine x. So we can just rewrite that. That's going to end up in the numerator, so that's going to be 3x squared plus 7. The derivative of sine is cosine over x cubed plus 7x plus sine x. So there we go. So that's the derivative, and that just uses the natural log function. Okay, so a couple of more things we can do when we focus on the derivative of the log function. Uh, we've talked about what the derivative of natural log is, but remember, natural log is just another way of writing log base e. So we haven't really talked about what the derivative rule would be for other bases. It's fairly easy to see. I've just put up one very simple example here so you can see how we get to that. Note that log base 5 of x by the change of base formula is equal to ln x over ln 5. If you want to recall what the change of base formula was, it said that log base a of b is equal to ln b over ln a. And by the way, this works with any base, so I could say that log base a of b is also equal to log base 97 of b over log base 97, that's a small 97 there, of a. So if for some reason I really wanted to know what log base a of b was in terms of log base 97, I could use the exact same formula. It's just going to turn out to be easier to convert to natural log because we already know what the derivative of natural log is. So the thing to recognize, of course, is that ln 5, although ln x is still a function, ln 5 is a constant, so this can be written as being equal to 1 over ln 5 times ln x. So now it's fairly easy to see that the derivative of log base 5 of x is equal to the derivative of this constant, 1 over ln 5, times ln of x. And we know that when we have the derivative of a constant times another function, we just take that constant and multiply it by the derivative of the function. So that's going to be 1 over ln 5 times 1 over x, that's the derivative of ln x, and usually we write this in the form 1 over x ln 5 like that. So, and in fact, I can show you the basic rule. Because I've written it in the opposite order, but it's the same idea. The derivative of log base a of x is 1 over ln a times x. The denominator is just ln a times x, and you can see that's exactly what we got here, finding the derivative of log base 5 of x. I'll just put up that rule. Let me just show you one other type of problem involving the derivative involving a natural log. So here we have find the derivative of natural log of 2x squared plus 1 over x minus 1. It would certainly be natural to just say, isn't this equal to, I'm going to take 1 over whatever's inside the log function, so 1 over 2x squared plus 1 over x minus 1, and then find the derivative of 2x squared plus 1 over x minus 1 by some very lengthy process involving the quotient rule for this part? The answer is yes, but there's an easier way. So the easier way, let's start over, say that d over dx ln 2x squared plus 1 over x minus 1 is equal to the derivative of ln 2x squared plus 1 minus ln of x minus 1. Because of the law of logarithms, it says that ln of a over b is just equal to ln a minus ln b. So now I just have the derivative of two functions involving logs, so this is going to be 1 over 2x squared plus 1 times the derivative of 2x squared plus 1, which is 4x, minus 1 over x minus 1 times the derivative of x minus 1, which is 1. So just to clean that up a bit, we get 4x over 2x squared plus 1 minus 1 over x minus 1.